Good morning. Today I'm going to be concentrating on what's called the cube root function. So we've done absolute value and square root so far. So we're going to worry about cube root today. So last year in 7th grade, you learned about how to find the cube root of a number. So it's a number times itself. Basically, the factor is multiplied by itself 3 times to get the number that's under the radical sign. So I'm going to start down here, which is a little bit easier, on the lower end of here, the cube root of positive 125, and that is actually equal to 5, because 5 times 5 is 25, and 25 times 5 is 125. And these numbers underneath here, the 125, 64, 27, 8, 1, 0, etc., those are all actually perfect cubes. The cube root of 64, and you can use this on your calculator. You can just hit the, I think it's second. Let's go grab my calculator 1 second. But the cube root of 64 is 4. The cube root of 27 is 3. The cube root of 8 is 2. The cube root of 1 is 1. The cube root of 0 is 0. And now we have the cube root of negative numbers. We can actually take the cube root of a negative number because a negative times a negative is a positive, and then a positive times a negative is a negative. So if there's an odd number of negatives, you end up with a negative answer. So the cube root of negative 1 is actually equal to negative 1. I'm just grabbing my calculator while I'm talking to you so I can show you how to do this. The cube root of negative 8 is negative 2. The cube root of negative 27 is negative 3. Cube root of negative 64 is negative 4. And the cube root of negative 125 is negative 5. Okay, I have my calculator now. So I am going to turn it on. And in order for me to do cube root, I need to do the math button. And on choice 4, below math, is the cube root. So I'm going to hit that, and inside I'm going to plug in negative 125. I'm going to right arrow out of it, and I'm going to hit enter. So that will give you the answer. Okay, so let's take a look at the next page. So the index, the little number on the inside, this time is a 3, and that stands for the cube root of 8. And we said it's equal to 2 because 2 times 2 times 2, or 2 cubed, is equal to 8. So what relationship exists between cube rooting and the number of a cube of a number? They are inverses. So just like square root and squaring a number are inverses, they're basically the opposite. That's the same as the cube root and cubing a number. Okay, they reverse each other's effect. So which one can be evaluated and why? So the cube root of negative 64 or the square root of negative 64. So I cannot take the square root of negative 64 because I cannot think of a number times itself that equals a negative number. So there's not like a negative times a negative, it always equals a positive, or a positive times a positive equals a positive. That doesn't work. But this one definitely does, because negative times a negative times a negative equals a negative answer. So the cube root of negative 64 is actually equal to negative 4, and it can be evaluated. The square root of negative 64 doesn't exist. Because it's not real. No number times itself equals negative 64. When you're in 10th grade and you're in Algebra 2, you'll learn about imaginary numbers and you'll learn how to take the square root of a negative number. But as of this moment, in your knowledge for what you know now, the answer is that it is not real and no number times itself is equal to negative 64. Okay, so let's move on to the next slide. So we're going to graph this continuous function shown in the table. So I actually graphed the points for you. They're on your paper. So negative 8, negative 2 is left 8 down 2, negative 1, here, 0, 0 is at the origin, 1, 1's right 1 up 1, 8, 2, right 8 up 2. So if I'm going to connect them, I'm going to put some arrows on them. So if you take a look at this one's sort of like heading down. This one's kind of going up. So do you know how we have like the word vertex for parabolas or for absolute value, and we have the starting point for square root functions? So for a cube function, it has a different word. It's basically, it says the concavity, where it's going concave up versus concave down, of the function changes is known as the point of inflection. POI. So the point of inflection in this case happens to be 0, 0. It's kind of where it's changing direction. Okay? And we're going to label this y equals the cube root of x. And this is the parent function of the cube root. That's what the parent function is, the one that goes through 0, 0, has nothing else done to it. If I took the cube of negative 8, I'd get negative 2. If I took the cube root of negative 1, I'd get negative 1. The cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. That's where these come from. State the domain as an inequality. It's negative infinity is less than x, which is less than infinity. There's arrows on each side. State the range, same deal, but this time there's a y. Negative infinity is less than y, which is less than infinity. State the function rule. So the function rule is the cube root of x. The function is increasing or decreasing over the time. So basically, if I'm looking at this, as I'm moving over my domain from left to right, the y values are going up. So therefore, it is increasing from left to right. Find the average rate over negative 8 to 0. So I'm going to do my work down here. So I have negative 8 to 0. Well, the cube root of negative 8 we got was negative 2. The cube root of 0 was 0. This went up by 8. I'm not able to put it. Okay, this went up by 2. So if I was going to write this, it's y over x, 2/8, which is equal to 1/4. Find the average rate of change from 1 to 8. So I'm going to make a new table now. I have 1 and I have 8. At 1, it was 1, and 8, it was 2. And I'm getting that from the table up above. It's going up by 7 and up by 1. And if I do this y over x, it would be 1 over 7. Is there a constant rate of change? The answer is no. So I'm still holding strong on the fact now we've done parabolas, we've done absolute value, square root, and now cube root. None of them have a constant rate of change. Still, the only function that we know that has a constant rate of change is linear or line. Let's take a look at the second example. So this time we have the cube root of x plus 2. So let's actually plug that in your calculator. I know it's actually done here for you. So I'm going to go under y equals, and I'm going to clear out anything that is in here currently. To get to the cube root, I'm going to hit the math button. And I'm going to hit choice 4, which is the cube root, and I'm going to put an x in there. I'm going to right arrow out of that because I do not want what I'm going to write now, the plus 2. I don't want it under the radical sign. So I'm going to write plus 2, and then I'm going to hit second graph to generate a table. So I do need to go into the world of negatives because those give me some nice numbers also. So I have a few numbers to graph here. I gotta see what actually fits on my graph. So I think -8, 0 actually fits on my graph. 1, 2, 3, 4, 5, 6, 7, 8. It does. I'm only going to graph the pretty numbers. So -8, 0. The next graph or nice point on my table is -1, 1. Then I have 0, 2, 1, 3, 8, 4. 8 4s over there. Okay, that's really all I can fit. So I'm going to draw my graph in. And if you take a look at it, it pretty much, I'm going to just call this f of x. It pretty much looks like the parent function except that it's shifted. So hopefully you're recognizing the fact that it's outside tells the truth. So what transformation occurs from the parent function? It shifted, shift up to. Where do you think the inflection point is? So this is your POI, point of inflection. It's sort of where the concavity changes. And this time it's not at the origin, but it is at 0, 2, which is basically coming from your h, k again. Remember, this is my k. This is my h. And there's nothing inside with that x, so it's 0. K is over here, which is +2. That's how I'm getting the 0, 2. All right, domain. -infinity is less than x, which is less than infinity. Goes on and on. Same thing with the range. -infinity is less than y, which is less than infinity. The function is increasing or decreasing over the domain, still increasing. All right, let's move on to the third example. So now I have a change going on underneath the radical. So let's go back into our calculator. Let's clear out what's in my y equals. And again, I'm going to hit the math button. I'm going to hit choice 4, which is the cube root. Under the radical, I'm going to plug in x plus 4 and right arrow out of that, and then generate a table. So you're going to get the same table that you see over here. Again, I like to look into the world of negatives because there are some nice numbers there and what fits on my graph. I don't think -12, -2 is going to fit on my graph. So that's too far for me. But I think -5, -1 will. So I'm going to go left 5, 1, 2, 3, 4, 5, and down 1. And then the next nice number is -4, 0. -3, 1. I'm going to keep scrolling down so I can see what's next. 4, 2 definitely fits on my graph. 1, 2, 3, 4, 1, 2. And then after that, the next nice number, long ways away, 23, 3. That's definitely not fitting on my graph. So I'm going to kind of have to sort of like go with this. It looks like that. And I'm going to call this f of x. And what transformation occurs from the parent function? So this time, from the origin, it's actually shifting left 4. What's my point of inflection or inflection point? It's at -4, 0. And again, comes here. That's my h and my k. There's nothing going on outside, so that's where the 0 comes from. Inside lies, so the +4 now becomes a -4 as my point of inflection. So domain, nothing's happening here. -infinity is less than x, which is less than infinity. Range, -infinity is less than y, which is less than infinity. What's happening with the function? Still increasing, okay? So that's pretty easy. All right, let's take a look. Now I've got silver and gold, and I've got combination of two things happening here. So I have a slide. Oh, this is just actually one thing. It's just one slide happening. So I didn't go crazy on that. Okay, so let's take a look. Let's plug in the function under y equals. Gold, if you want to, head over to that, and I'm going to do the sum it up in between silver and gold just so my silver friends can turn the video off. So let's start with silver. So I'm going to clear out anything that's on my calculator. I'm going to plug in the math button. I'm going to hit choice 4 for cube root. Underneath my radical, I'm going to plug in x minus 1. I'm going to right arrow out of that radical to type this in correctly, and I'm going to plug in minus 3. And then I'm going to hit second graph to generate a table. So I'm going to scroll around till I see points that actually fit on my graph. So I see points. So 0, -4, 1, -3, 2, -2, 9, -1. And even lower. So it's actually graphed for you. So I don't even have to really think too much over here. I do have to answer the questions though. What do you think the inflection point is? So that's basically where the concavity is changing from heading downward to heading upward. And I'm going to go with 1, -3. I can look at my graph and realize that. Or I can look here for my H and my K. And again, inside lies. So if it says -1, I wrote +1. Outside tells the truth, so my -3 becomes a -3. The domain, -infinity is less than x, which is less than infinity. Goes on in both directions. Range, -infinity is less than y, which is less than infinity. Is the function increasing or decreasing? Still increasing. What does the square root of x minus 1 tell you? Does it control the horizontal or vertical shift? The answer, it's shifting it horizontally, and it tells me shift right 1 because the inside is lying. What does the -3 tell you? That's the vertical shift, and it tells the truth. It's shift 3 down, or down 3. Okay, so let's take a look at sum it up. And then I'm going to head to gold. Using your calculator, graph the following two functions. So this is my square root function. And this is my cube root function. So we're basically comparing two things we've done. Compare the two functions. So how are they similar? They are both increasing. Oh, the answers are here for you. This is so nice. How are they different? So the square root of x has a restricted range because it can have no negative numbers. Just can't find the square root of a negative number. We talked about that in the do now. The cube root of x includes all real numbers. That's why it's negative infinity and positive infinity. I'm sorry, this number goes here. I apologize. So it has the square root of x does have a restricted range because the answer can't be negative. So square roots are never negative. The domain is what I was talking about before, can't take the square root. Square root of a negative number. So you can't have a negative x. And you can take the cube root of a negative number. So that's all real numbers. So square root of x has a restricted domain. Cube root of x includes all real numbers. So that's important for you to realize that they definitely have a difference going on. All right, Silver's going to shut off here, and you're going to work on your Google form, which is due on Friday. Gold's going to stick with me, and we're going to take a look at gold 4. This has two things going on. It has a dilation because it has an A of 2, and it has a translation because it is sliding. Okay, so let's plug this in our calculator. So it actually is asking to plug 3 things in your calculator. I'm going to stick with just this one thing. So I'm going to plug in a 2, with a cube root. So I'm going to hit the math button for cube root of x minus 1 under the radical minus 3. So the only difference between this is silver, just didn't have the 2 in front of this. So I'm going to hit my second graph and generate a table. So you actually have to graph this. They didn't graph this for you. So I'm looking, I think -7 actually fits on my graph. So I'm going to look for that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, fits perfectly. The next nice point is 0, -5. 1, 2, 3, 4, 5. Then I have 1, -3. 1, 2, 3. Then I have 2, -1. I'm going to scroll down a little bit. 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to stick it in there anyway, even though it really doesn't get there, but it's going to help me graph this a little bit better. So I am going to connect. So this definitely got stretched out. Do we agree? Definitely looks stretched out. But we can still find the point of inflection. It's still 1, -3. And you can look at your graph, or you can look at H and K. And again, inside lies. So if it says -1, it's +1. Outside tells the truth. So -3 means -3. State the domain, still -infinity is less than x, which is less than infinity. State the range. The y values are also going from -infinity to +infinity, or all real numbers. The function is still increasing. What is the cube root of x minus 1 tells you? That it's shifted right 1. So silver and gold are pretty similar. It's a horizontal shift. The -3 tells me shift down 3. And that is a vertical shift. What is the scale factor? That's the 2. Does it indicate a stretch or a shrink? So if you look at the function, it's definitely stretched out. It didn't get skinnier. It's definitely stretched out. So we're going to say stretch. Okay, so this ends my lesson on cube root. It's pretty easy. And you guys are going to stop the video and please do the Google form that I attached to Google Classroom. Okay, bye.